Here. Today, I welcome all of you to a session on data analysis with Python for beginners. This is a session for beginners and it talks about some libraries of Python that you could use for machine learning or data analysis, etc. To begin with, I'll talk a little bit what Claudics Lab is and what Claudics Lab does. Uh, so, so Claudics Lab basically is a edtech platform that tries to make learning fun and available for life anytime, anywhere. We got videos, quizzes, hands-on projects, and case studies. All in together, we make real-life use cases so that it makes machine learning, big data analysis very real and very useful for practical reasons and makes you job ready. Claudics Lab is a playground with feedback. So the playgrounds are for hands-on. The system evaluates. So the way it looks something like this, where there is content on the left-hand side, and there is so content would have instructions, will have some theory, etc. on the left-hand side, and on the right-hand side you've got what's called a playground, a Jupyter playground, where you could type in code, and this code then you could type in code and then you can press submit. When you press submit, the code you've written here gets evaluated against the test conditions for this particular instructions, and in case your code is correct and does what and you have to follow the instructions correctly and you have solved the problem, you get answers and you can move forward. If you can't, there are hints, you could even get the answer at some loss of a few points, and there is also a comment section which you can interact with your fellow learners and with the TAs who will be supporting you. So the Claudics Lab, it comes pre-installed with a lot of software for practicing AI, machine learning, deep learning, big data technologies, all in easy. So what you never don't need to do is you don't need to install anything, and you can come and get started with it directly. So Claudics Lab, as I said, is an online cloud-based labs. We try to bring real problems. We have central data sets so that you don't have to upload too much data. You can get your own data, and also do processing on Claudics Lab if you want to do some things. The real nice advantage that Claudics Lab brings is that it's a seamless experience. You don't really need to do any downloading, installations, etc. I think there are already some questions. There are already some questions about Python installations in the comments section. So what I want to highlight is that is not needed when you're working at Claudics Lab. So for beginners who are starting and who don't want to get their who they don't need to get their hands dirty with installation issues, downloading, etc. And you can get started easily. The very nice thing is everything runs on a browser, so that means you can log in with any device just using a browser, any Chrome browser, Mozilla, or Edge, from any kind of system. You can log in and learn anytime at your own convenience. So Claudics Lab, one interesting thing it has social interaction. So you can see other people who are learning with you, and it's got a leaderboard that shows you your engagement, where you stand against your peers, and it's got a discussion forum. It's got a comment section, which is again a place where you can interact people. So what it tries to do is we try to bring in a classroom experience remotely online. So that's something which you guys could try. There are lots of times a lot of interesting questions and discussions on the forums, which means that a lot of the things you want is already solved. Okay, so that is how the lab works. So in case you have questions, please send the questions on YouTube forum, and I will keep answering them as we go through. Okay, there's one question. There are a bunch of hellos and good evenings from people. So, hello and good evening to everybody. I hope all of you are enjoying the class as much as I will. We're just starting. There, Mohan asked, does Claudics Lab charge for anything to practice Python, data sciences, etc.? The lab, yes, has a minimal charge. So you can so there's a lot of content that's available for free. I'll start this way. There's a lot of content available for free for you guys to just browse through. We have an audit mode which you can take and you can look at your classes. Then there are free classes that we also provide. There, the lab which I meant we spoke about is free for the first 15 days. So you can try. It's very generous, and you can try it for the first 15 days, and you can take a decision of how you want to proceed with that later. Okay. So that's there. So as I mentioned, yes, we've got engagement, we've got ways in which you can interact with your classmates, etc. And so Claudics Lab also has hiring partners, a dedicated job portal which helps you create your career and improve your salaries, and we've got hiring. So we have a job portal where people keep applying for jobs, or our hiring partners keep uploading them there, and that's one way in case. And then also share. We share interesting profiles with our hiring partners, so it's a great way to find. You can do it along with your normal work. You don't need to stop work. Okay. So the content in this for which I'm presenting today has been also been prepared by Sandeep, who is the founder of Claudics Lab. He has a lot of experience with Amazon, InMobi, D Shaw, etc. He loves teaching. He loves AI. He loves computer science. And yeah, and if you join our classes, you will definitely come across classes given by him. The other guy who's contributed his class is Abhinav Singh, who is also a co-founder at Claudics Lab. His experiences are in AI, ML, big data, also DevOps. He is also a visiting faculty at SCMHRD. He's got a lot of experience in both gaming and edtech with Byju's and Hashcube, and adds a lot of theoretical and real knowledge, real content to our classes. The guy in the middle, that's me, Praveen. I'm also the CTO and co-founder of Yatis, which is an IoT company, IoT for vehicles. We do IoT. So my interests are in IoT, machine learning, computer vision, especially at the edge. So I got degrees from IIT Bombay in electrical engineering, and I worked for several years abroad and in India. And I've worked in multiple aspects of technology and management, and yeah, and my interest, as I said, I'm trying to focus on machine learning, computer vision, and combination of edge and IoT. Okay, there's a question from Gandharv Katyal of how to apply for the MS program. Gandharv will be launching it very soon, so just so you could either subscribe to if you've registered with us, we will definitely send out more information. We are kind of just cleaning up the plans for this course, and as soon as we are ready, we will be launching it. It should be in a month or two. We'd make a more public announcement for everyone and announce the procedures of how to proceed forward. Okay, now let us come to the content. So let me be clear, the class today is going to be hands-on. I will just have a small section which is presentations and talking. We will soon get deep down there's this code. So the people who register, we will provide the link to the GitHub. We'll provide access to the code, access to this presentation, and this video is going to be available on YouTube for life. So you can access that anytime. For the people who I don't really recommend people to follow or for do the code along with me. It might be too fast. So you can watch, and in case of questions, please shoot the shoot. I will keep answering them as we go forward. So what is Python? Python is an interpreted high-level language, so it doesn't have a compiler. It's a high-level language, so it's not a. It's so we write fairly high-level commands. So it was invented in 1991 by Guido van Rossum. It was invented by 1991 by the Dutch programmer called Guido van Rossum, and it's one of the real advantages of Python that it's very easy to use and it really improves engineer productivity. It might not be the most efficient language, like writing the same code in C or C++ might give you more efficiency. The code might be faster, or if even better, if you write it in a low level language like assembly, it will be even faster. But the real advantage of Python is that it's really easy to write, it's easy to read, and therefore easy to learn, and therefore it dramatically improves engineer productivity. So this is often a question, hey, if it's slow, why is it so popular? The really important thing is to have engineers to be more productive. If your engineers are more happy and find it easier to do something, the overall productivity is much higher. And there is a small hit on the performance of the code, but that is all right. And as you've seen, so Python has become the most popular platform for machine learning and AI. So but again, so nice thing about Python is a lot of libraries for multiple applications. So in case you're looking for something like a web application, you want to build web application, server-side web application, then Django is a platform that you would use to make web applications. So what we do today is we're not focusing on Django or any web applications. Our focus is very clearly on the libraries that are focused on data analysis. Okay. So there are so some of some of our support people and our engineers are online, and they will be answering your questions. So in case I can't answer them, they will answer them. Okay. So Sunil Rawat asks questions. Once you have completed the course, what is a good place to practice the skills for any projects that can be done later on? So I'm going to add two things. One is, so Claudics Lab today has these things called guided projects. So some of the guided projects are actually projects that have guidance and they are gamified, so it's easy for a lot of people to follow and do it. So that's, I think, one place to start. As you get more and more experience with the problems that we've given, and you feel you're ready to do more, Kaggle is a really good spot to take up real problems in data analytics and AI, and that's one spot you would love to do. Okay. Okay, so the first library we will be talking about is called Numpy. Some of you might. So what is Numpy? Numpy stands for Numeric Python or Numerical Python. It is open sourced. It's a module of Python. We will see how to use it. It provides very fast mathematical functions. So very interesting over here is that sometimes the same functions are available in normal Python, but if you use the NumPy version of it, it is significantly faster. Now, one of the reasons that happens is that NumPy is a library that's written specifically. So NumPy is a library written in C or C++. Some of these functions are in C or C++, and the engineers who wrote it did a lot of optimizations at several points to make sure it runs much faster. So there are certain functions like, say, find like multiplication of two matrices, or looping through an array and running an operation on top of that. Some of these functions are you could obviously write a for loop and loop around the matrix or the array and get a result, but you would get a faster result if you use numerical NumPy. Besides that, NumPy also has a bunch of things that make it really easy to use. So now this is like an overview of a bunch of tools in Python which contribute or together can be called the complete machine learning ecosystem. Python is here, and I said everything is Python, so it doesn't matter. So NumPy is what we'll be talking about. So at a very simple thing, you could say it's a bunch of libraries for you to manipulate lists. Okay, it's as simple. It's a lists with a lot of different functions. A list with a lot of functions are specifically written, and we will see a lot of them today. And with these functions, you can make a lot of with these functions you can do a lot of you can solve a lot of problems. So what we'll be doing today is we'll be just showing an introduction upon the tools that are available in NumPy. If you want to get further in, you could look at some of the projects that we have online, and you can take a look at that. We have some very interesting you can actually write an entire machine the entire an AI and complete AI tool in just NumPy without using other things like TensorFlow, Scikit-Learn, etc. It's possible. It's more cumbersome, but it's possible. So NumPy is by itself is quite powerful. The other tool that we'll be looking today at is Pandas. So Pandas is the closest, the easiest. The people who have not seen, I think the best thing to talk about Pandas is like Excel, like an Excel sheet where you can put data in rows and columns in a table, and the data can be accessed and processed on, and you can do a lot of interesting things with that. Okay, that is the Pandas, that is the best thing. So we will also take a look at Pandas today, and we'll also have cover a smaller introduction to Pandas. And the next library which we'll hint upon is Matplotlib, which is a library of library to essentially plot graphs. Okay, to essentially plot graphs. So those are the things which we will be covering. There are other applications which are there's an entire platform called Scikit-Learn. So Scikit-Learn is the machine learning library for Python. So Scikit-Learn comes with a lot of machine learning algorithms like logistic regressions, linear regressions, decision trees, etc. So that's when you get into machine learning. Scikit-Learn is a package that you would use. TensorFlow is a package which you would use more if you get into AI and deep learning and have to work with neural networks. That's where TensorFlow is useful. Now, NumPy comes in the middle because all of them actually use components of NumPy. At the core of it, there's a lot of the background processing or the background data structures, the bottom data structures are all based on NumPy. So why use NumPy? It is array. It uses basically what it said. It's array-oriented computing. It very efficiently implements multi-dimensional arrays, which I mentioned. Okay, it's designed specifically for scientific computation, and it's a library of high-level mathematical functions. So again, as I mentioned, so I'll just go through this again. As I said, it's basically an array or a list with a lot of very specialized functions written for it, which makes it very efficient and also is very powerful because it just gives you lots of choices to do, and we will see some of it today. So NumPy introduction. So NumPy's main object is a multi-dimensional array. It's like a table of elements, usually numbers, all of the same type typically, and it's indexed by a tuple of positive integers, very much like an array. So in NumPy, the dimensions are called axes. That's one little thing. So because it's a multi-dimensional array, there can be multiple dimensions, and those dimensions in NumPy are called axes, and that is important. We will see what that is. So number of access. So if you have, which we now we'll come to that. The number of access is called a rank. So it's called a rank of that particular array. So if you've got really a very simple array which is just unidimensional, the rank is 1, and if it's more complicated like a matrix, the rank is 2, and if you have something more complicated, your rank could be a much higher number. So as I mentioned, in case you have something like this, which is a matrix, a 2 by 2 matrix of all zeros, the rank of this, now that is basically, it's got one axis along this and one axis along here, and it says that the rank of this matrix is 2. It's two-dimensional and the rank is 2. That's what a rank means. And now that's very similar like rank of the matrix, which you may have studied in high school. Now Numpy array. Now what I'll do is, again, I'll be using a combination of slides, and then I'll be jumping into hands-on with my notebook to do the actual demonstration. Okay, so Numpy arrays can be created from basically both Python lists or tuples like this. So we first have to import Numpy as np, and you can declare A as an array. So as you see, A is an array, and if you print type of A, you get what A is. Similarly, you can just declare B. Here we have declared B as a tuple, and that also can be declared into a Numpy array, and that works all fine. It's not an issue. You can declare in multiple ways. Now, one important thing is that sometimes what you want to do is very often you want to declare an array that's just all zeros, an empty array, and Numpy just lets you do that. So you can declare a matrix or an array that's multi-dimensional, can have its rank could be something, its size could be anything, and you could just declare, and you could easily declare an array of all zeros. If you can do all zeros, well, you can do also all ones. So previously we used np.zeros to create an matrix or an array with just zeros. If you use np.ones, you can create one with you can create a matrix that's all ones. Here we have created np.ones of size 3 into 4, so it's basically a matrix with 3 rows and 4 columns. The type of the variables you have defined, call it to be an integer 16. That's an option which you could do. Now the other option you have is you don't want zeros, ones, but you have a fixed number. That's also easy to do. You can use something called np.full, and here we have done np.full, again created a 3 by 4 matrix where everything is put with 0.11. And all these options are very easily available. You can just do that by default. Now, what you can also do is you can create a sequence of numbers using the functionality called np.arange. So here, np.arange, I've specified here, we said that we put 3 numbers here, 10, 30, and 5. Now, what is the syntax? Syntax here means that please create an array or a Numpy array that starts from this point, and then you keep incrementing from this with the last number here, 5, till you reach this number. Actually, you don't reach, you stop before that. So this is the maximum number you're just supposed to stop before that. Okay, so if you wrote a command np.arange 10, 35, what you get is, as you said, first one is the first number in the array is the first number here, that's 10, as you can see here, 10. The next number is an increment of 5. So increment 10 by 5, you get 15. Again, increase by 5, you get 20. Again, increase by 5, you get 25. Increase by 5, you would have got 30, but it says up till 30. So it is up till 30. So till before 30. So you don't reach 30 and it stops there. Now this is not only integers, you can You can also get the same function. You can create a series of these numbers if in floats also. That's also optional. So for example, here I've said that give me a array that starts from 0, goes all the way to 2, but the increments are at zero point 0.3. So again, so start at 0, I've got 0.3, 0.6, 0.9, 1.2, 1.5, 1.8, and it stops before 2. So another way in which you can declare multiple things. Okay, now there is another way, which is to create an array of evenly distributed numbers or created by a series, and that's called np.linspace. Now the way that works is it returns an array with the specific points, evenly distributes them between 2 points. Okay, but what is that? The maximum value is included. So if you remember, when I use np.arange, the maximum value is not included. In this case, the maximum value is included. The other difference is that whereas in np.arange I gave the step size, here I don't give the step size, I give the total number of points that's needed. Okay, total number of points. So let me just refine what we did between np range and np.linspace. Both of them can create sequence of numbers from a starting to an ending point. In range, you don't get your maximum point, which is the second number, where while use linspace, you also get the ending point. In range, you basically specify the step size, and in Linspace, you essentially specify a count, the number of points you need. You can do more things. You can create random arrays. So you can create an array of random numbers that's just a bunch of random floats between 0 to 1 by using an inbuilt function in Numpy called np.random.rand. And here we have created a random an array of dimensions 2 by 3, a matrix of dimensions 2 by 3, 2 and 3. So there are 2 rows and 3 columns. And they're all random numbers between 0 and 1. So this is just one screenshot. I'll again demo it and you will see all this happening. You can also create something called np.empty, which is an empty array, and lots of times it just gives any random. It's also like a random number, but without absolutely any focus, and it can be anything. So np.empty also gives you an empty array with uninitialized, what you say, and it's just random text. It's usually just random noise that's been generated by some items that's just left in the RAM component. Okay. Okay. So what I'll do is I'll jump to our hands-on. So there's a question from Rajiv: is random generators generated using a uniform distribution? This one uses, I believe, it's a Gaussian distribution. You can also create uniform distribution based ones. Okay, now I'm basically going to the lab and I'm starting. So the Claudics Lab would look something like this, and I'm starting up the Numpy notebook, and I'll be demonstrating that. Let me just close the notebook starting up. Cool. Okay, so for the folks who have never seen Python, or some folks might have seen Python, so the Python, as I mentioned, has a lot of libraries. Now, every time you're using one of those libraries, you have to import it. So NumPy typically comes pre-installed. At least it's pre-installed on Claudics Lab, so that's not an issue. And if you have a library that you want to include in your program, you can import it using a function like this. So this says import the library, and we'll call, and that we will call it NP going forward, because NumPy is too big, so we will call it NP. Now this is like a standard nomenclature which has become extremely popular for in the Python universe. So wherever people are using NumPy, they usually import it NumPy as NP. Okay, so some folks have seen it, and some folks may have, but this is the way it's going to be. And you need to do this. Like, this is the first step. And if I, for example, and this is again what's called a Python notebook. So some people have not seen what a Python notebook is. So Python notebook is this. It's called a Jupyter notebook. It comes with an interface like this, and what you can do is you can write code here. By default, the code is not all executed. We can execute that step by step. For example, I can just click on run cells and it would run it. Alternatively, but what I'd be doing is I'd be using a shortcut. So for me, a shift and enter is a shortcut, and when I do it, it gets executed. So as you see, I just executed this particular function, and now NumPy is ready for me to use. Okay, so now as I mentioned, so now we will be demoing actually running the code and doing some exercises for people to see what's happening. Okay, so our first section, as I said, is the declaration of Numpy arrays, and as I mentioned, Numpys can be declared in separate ways. So an easy way of doing it is by declaring it A as a np.array of, and internally we have specified a list or an array, as you can see, of 1, 2, 3. And I executed it, and I have now created A is now an array that contains 1, 2, and 3. Now, most importantly, what NumPy is basically an n-dimensional array. And in Python, if you have any kind of object, and if you want to find out what type that object is, you can write type A, and it'll tell you what that is. It's the type of the function is an ND array. It's an n-dimensional array, a NumPy n-dimensional array, and that's what almost everything is going to be. And the number of dimensions in this array is 1. Well, this is just repeated again, doesn't matter. The other method of defining an array is by, so earlier we had declared np.array, and we had used two square brackets. When using square brackets, that's usually an array. And over here I've used normal curve brackets, and this case I've used basically to declare a tuple. And for an NP array, it can be declared based on a list or a tuple, doesn't really matter. And again, and if I look at what is type of A, it's the same. And okay, so now I'm going to tell you about a concept of shape. So shape basically specifies the dimensionality of an array. So to start with, as you can see, this is right now is just the B is just an array of 3 numbers, and so it just says 3 and nothing else after that. If it was multi-dimensional, you would see more numbers over here. So this is a single dimensional. All you see is B with just one value here. So and just there are 3 items in this. So the shape is 3, comma nothing. So it's a single dimensional array. If it was a multi-dimensional array, you would see more numbers here, each for a particular dimension. Okay. Cool. The next thing is array with zeros, as I had mentioned. So you can declare a multi-dimensional NumPy array with only zeros. And as I said, just np.zeros. So here we've declared a multi-dimensional array, a 3-dimensional array, and it's all considered to have just zeros. So what is it? You can see it's 2, 3, 4, and what we have is essentially, you can see you have 2 matrices. That's the 2 here. They each have three columns. Sorry, three rows and 4 columns. Okay, so that is like a way to look at. So when you're working on 3-dimensional arrays, so I have 2 arrays I have two matrices, and the dimension of each matrix is three rows and 4 columns. And as I mentioned before, if I ask you to write the shape, you would actually get the same number as this, which essentially says it's got two matrices, 3 rows, 4 columns. It's like a three-dimensional matrix. And the number of dimensions or the rank of this matrix is 3. Okay, so that's the n dimensions. So I'm just clearing out all the definitions which are or the basic syntaxes and the basic definitions of a few items that we'll be using, just clarifying all those items as we go deeper and deeper. And so I can again do something very simple. I can just declare, if I just declare three variable, if I say np0 is 3, it just creates a simple an array with 3 elements, all of them zeros. I can also do a 2-dimensional. By default, its type is double. That's what it says. And the shape here is x.shape. As I said, is 3 by 4. So as you can mention, the same here. Basically means 3 rows and 4 columns. The next step, as we mentioned, as you can do zeros, you can do 1. So Rajiv asked, basically a tensor effectively of rank 3. Yes, Rajiv, that's correct. It's basically a tensor of rank 3. So you basically take the same concept, and when you go to TensorFlow, you just call them tensors. And so here you can do the same thing with ones. If you just want something full of ones, you could do that. Well, the types, everything here is float 64. And as I said, if you want to have a declared value, so you want to know how a fixed value for your Numpy array, you can do that by using np.full. Similarly, we've done again 3 by 4 matrices of shape 3 and 4. You can do something more complicated. You can use constants like np.pi gives you access to a great pi, the constant pi, to a particular level of accuracy, obviously. And you can do that. So if in case you need pi or some of the variables, you can use that. The other one which we had mentioned was np.arrange, which we said with which you can create an array that starts from 10 with steps of 2 but stops before 30. And when I execute that, you get CC 10, 12, all the way up to 28, just stopping just before 30. Even if I had this at 29, I would effectively get the same answer, 28, because it's still before 29. But if I kept this as 31, I would get 30 also. And np.arrange also supports floats. So here I've created an array starting from 1, going all the way, stopping before 100 with steps of 0.1. And here you can see that can be created also very easily. np.arrange, again, you can, this is another example, when you do 0 to 2. Here we have gone from 0 to 20 of 005. So as you can even count and see that if you have a step size of 0.005 starting from 0 to 20, you'd get 4,000 points. You can see that 20 divided by 0.005 will give you 4,000. And in case any doubts on that, I will just show that to you. So if you just have 20 divided by 0.005, 4,000. So that's exactly the same. Okay, so the other way of declaring is you can actually write down your matrix. So if you have something complicated like over here, we have basically we have it's essentially 2 by 4 array. So it's 2 arrays of size for each, and you can actually write it down specifically and then declare an array using declare a Numpy array using this array as the input. and that also works. Okay, here we have an example. So there's a lot of examples here. A 3D array. Okay, now we're going to talk about certain functionalities that are available um, with Numpy arrays, which make it easier to manipulate. So a lot of times when you go and you start playing with Numpy arrays uh, with certain exercises with machine learning or AI, you would often need to manipulate the size of the data. So as somebody had even mentioned that these are like tensors, yes, and the size and the shapes of these tensors have often to be manipulated while doing machine learning, etc., or have to be changed. So NP gives us a lot of capabilities to do that. Now we're just stepping into that. Now, to begin with, it's got a very simple thing called size, which gives us size of the array. Okay, so it's basically size of the array, and well, we can't. Let's see if we can see this array. It'll look very weird, but let's try a. No, sorry, x. And so these are a couple of shortcuts. If I want to add another, say another entry in this, I can press. If I press A, I will get something above it like this, and if I press X, it goes away, and if I press B, it adds something below the current cell. It adds a new cell below the current cell where I can put in something. Okay, so that's something, and the same functionalities are available again over here. For example, I can cut it. I can cut it, and if I want to add, I think I can just add cells here. Move cells up. Yeah, insert cell above, insert below. I can. So similar functionalities that are given here on the menu size, a lot of them are available in shortcuts, and so I'm just going to add one cell above. I'm going to say print 3D array, and you can see what it was. Essentially, it was two matrices of size 3 and of size 3 by 4, so 3 rows and 4 matrices, 3 rows and 4 columns, each having 0.11. If you don't like 0.1, you can even call it something else. So for example, if 0.13 was a lucky number for some reason, whatever, you can have that. And if you count the number of points over here, you can see it is 24, which is also comes by 2 into 3 into 4 is also 24. You can also count this and see. And that's what it says. That's what size is. Size is the number of elements in this array, in this Numpy array that we're using. Okay, so the next function, as I said, we're going to talk about is how to manipulate these arrays. So to manipulate the array, one of the things what we'd like to do is we like to change the shape. So as you see, the shape of this is something like this: 2, 3, 4. It looks like this. There are two matrices, each of size 3 by 4. So Numpy provides a very easy function if you want to declare, you want to make it, you want to change the shape of it. So for example, this particular function, this particular command, what it does, it basically changes whatever array into arrays of 4. Okay, into multiple arrays of 4. That's what the -1 says, that okay, just look at the next number and I want arrays of that size. Okay, so you want, so it gives an array of these arrays, and each of the arrays has size 4. For example, it's 24. I could have alternatively even put 12, and if I get 12, as you will see, I will get 2 arrays of each of size 12. Okay, and if I could have instead even put 1 -1 by 1. This is actually a very famous command. It just makes it takes each element and puts that into array. This is something that's used a lot in machine learning. This shape is used a lot. Alternatively, and you can keep changing the shapes with this. Please note that almost all the commands I did not really change the shape of the array. It just temporarily created one. If I go and check what the original shape was, the original shape is preserved. If I wanted the shaped array, I would have to assign it clearly. Only if I assign it will the shape change. If I don't assign it, the shape stays the same. Okay. Neat. So again, other ways of declaring arrays, not particularly important. Right. Now, as I mentioned, the other way of declaring Numpy arrays as a series of numbers using the command Linspace. And what Linspace does, it specifies the min, max, and the total number of numbers in between, or you could say numbers in between, the numbers in it. So we said 0, 10, and 3. So if we run it, we get 0, 10, and 5 in middle. So, and it says, and you've got 3 numbers as we've specified here. Similarly, if we use something like 0, 10, 50, what we would get 0 and 10 with 50 numbers in the middle. A total array of 50 numbers. And as you can see here, it's got 50 numbers here, each having a step size of effectively 0.02 something. And there's some noise over here in the last decimals, which is something we got to live with. So we can even use these numbers can even be so the max number can also, min and the max number, both of them, they can be fraction floats also, not a problem. That works very well. Okay, so now, like for example, a lot of times we work, so I've been talking about dimensionality and using arrays. So one of the big uses of machine learning and deep learning has been in computer vision or manipulation of images. So in case what, suppose we have a list of images, okay, we've got the dimensionality of that would be 4. Okay, so if you ever do that, if you ever work, that's how it's going to look. That there'll be 4 dimensions. The rank is going to be the 4. The first dimension is going to be the number of pictures. So if it's the first picture, second picture, third picture, etc., an index that tracks and then which number of picture you're looking at. The second one will be the x-axis. The third one will be the y-axis, and the fourth one would be R, G, and B. The RGB values of the pixel value of the red value, the green value, and the blue value. Some of you might be knowing it, some of you not. All pictures are essentially represented as RGBs, and so if you ever work with, and each picture by itself is usually a 3-dimensional object, and if you're working with a batch of them, so an array of images, you have to add a 4th dimension to track the dimension or the number of the picture. The next thing we had spoken about was a Numpy array with random numbers. And as I said, np ran 2 by 3, you would get that. If you use something np.empty, you actually can get anything you want. It's absolutely no idea what you can get. This one is actually a random number between 0 and 1 all the time, so there's some control over here. This is some random. You could get anything you get. Sometimes it could be perfect zeros also. So oddly put, I think there's some weird. So let me just check if that happens this time. Right, so now for some reasons these numbers have already been created. So when I created an empty numpy object of the same size, it just took these numbers as is and put it over here. Okay, just because these numbers were somehow created. So what you get on np.empty is you have absolutely no idea what you'll get. You could get anything. So Just keep that in mind. Okay, cool. Now I'll just give me a second. So create an empty, right? So there are some properties. You've seen some of these properties. So one of the as a lot of us have seen, the Numpy array class is called an ND array and an n-dimensional array. The attributes of an n-dimensional array. So there are a lot of properties for n-dimensional array. One of us is obviously the number of axes, the number of dimensions. For something like this, it's 2. We've seen that. We've seen hands-on examples of this happening. Okay, sorry. The next thing, a very related topic, is the shape of it. The shape kind of defines the overall the size of each little object at in each dimension. And so if it's something like this, what it is basically is, as a lot of you people could see, it's basically a matrix of which has 2 rows and 3 columns. And if you ask it for the shape would be 2 comma 3. The size of this is actually the total number of elements in the array. This is also something which you've seen, and it can also be the product of the elements of the shape. So the shape of this would be 2 comma 3, and the size of this is 6 because it's got 6 elements in it. Ramji Kishore Gundapalli asks, will data analysis be considered to this? This is an introduction. So this is an introduction to the libraries that you need in data analysis. In this chapter, we do some overviews of things, but we would not be solving a problem. We'd just be giving overviews of the libraries that go into data analysis. So D type, it tells you the type of the elements in the Numpy array. Typically, all the elements in the Numpy array have the same value. So over here, the D type is int64 or double. An item size, this other thing is called C.item size. It returns the size in bytes of each of the item. So here each item is 8 bytes, which makes sense. Then the reshape value. Okay, then we discussed reshape. Reshaping can change the shape of the matrix, which is something we have seen. Cool. So we have seen these. I think let's make sure I have just completing all the sets of this. So just repeating the properties. So I have created X. There's n dimensional, so it's number of dimensions. You can ask for the shape. You can check the size. Validation, you can check what the array looks like. It looks like this. You can access each parameter also if you want with x comma 0, x comma 1. So as you say, x comma 0 gives you the first row, x comma 1 gave you the first row, x comma 1 gave us the second row, x comma 1 comma 0 gave us the first item or the first item in the second row. Oh, sorry, I have to let me execute that. Yeah, 0.85. Since I'm using random numbers, it's going to be a different number every time. And again, I can access this by either by 1 and 0 in separate square braces, or I can put just 1.0. The net result is the same. C.np.a range 1 comma 5. See in this stuff. So if in case I declare something like this, you can check the D type. Each of these items are basically 64-bit ints. Item size, the size of each item is 8. np.a range, if I declare something like this, right? So this is just this is how you reshape an array. So if I had an array with 24 items, I can reshape it to by default first it was something like this. It was just 24 items like this, but I can all shape it into something like 2 comma 3 comma 4, and I would get, as I say, something which we've seen before, 2 matrices. each of rows 3 and columns 4. And I can break it back. If I just say b reshape -1, it would just bring it back, just flatten the whole thing out. Okay. Prashant asks, can we have elements with different data types in an array, not an not a Numpy array? Typically, Numpy array won't let you do that. Numpy arrays, you typically want all of them with the same type. So here we have a random. We have now created a random array with random numbers. By multiplying by 10, we have said by default this gives you numbers between 0 and 1. By multiplying by 10, it's given us a value from 0 to 10. And as you can see here, I've created, this is more reshaping. There are a lot of examples of reshaping over here just to make clear what reshaping is doing. So here I've created something of A with 50 elements, and by reshaping it, saying minus 1 by 5, I have asked it to give me arrays of size 5 and how many ever they are. If I made them 10, I would get arrays, 5 arrays of 10 elements. Okay. Okay, so now if you want to access Numpy methods, or like for example, you're in this in the Jupyter forum, and you want to access. So for example, if you know about this thing called np.sum, and you want to say, hey, what does that mean? You just need to write np.sum, put a question mark, and execute that particular line, and what you get, you get the documentation of that particular function. This drops up. Okay, it just drops up, it just comes up easy like this, and you can take a look at it. Okay. So Raman Jangra asks, can we perform mathematical functions using the elements of the array? Raman, we are coming to it. We will do that. Okay, so we will direct. So if you want to see all the properties and all the functions that are part of Numpy or anything in this notebook environment, you can use this. You can use a command dir, which is directory. So it says dir of Numpy, and if you execute that, you get all the elements, all the properties, and all the methods that are available in Numpy. So you can see how rich it is. So somebody just ask, can we do calculations? Look at the number of things you can do with it, and it's just got lots of things to do, a lot of things we don't know also about. And if you have doubt about something, all you can do is you just put that over here. For example, if you want to see np.lcm, and you say, hey, what is np.lcm? So I saw np.lcm here, and I say, hey, what is np.lcm? We could put np.lcm question mark, enter, and it would give me, as it says, returns the lowest common multiple of those two numbers. So there's a lot of things. It's almost very difficult to learn all of it. You just have to know how to do it and how to access the documentation, and all that is available. The next thing we're talking about is how to index and accessing these Numpy arrays. Let me just present. So we're going to start with a one-dimensional Numpy array. So typically, if we have an array like this, and this is the index, you can just access it by the index. That's easy to do. So if you wanted the third item, so n8, 3 would be 19. Other things you can do is you can do what is called slicing or getting a range of it. So if I wanted to access a range, if I gave 2, 2 colon 5, I'd get everything from 2 till before 5, so till 4 essentially. So I'd get something like this. The other method in which I can access slices or parts of it is by this concept of jumping, if I add a third dimension here. So what this one tells me is how to jump. Okay, so this particular functions, as it says, a 2, I've got nothing here, and 2 here. So what it says is start from index 2, go till the end of it, because nothing specified. That basically means go through the entire array with steps of 2. If we execute that, what we get is it'll start from 2 and take 2 jumps. So you'll get 3, you'll get this value next, that's 13, and you'll get this value next, that's 3. So that's how this would get to do that. Okay, so these are essentially slicing of arrays. This is what the whole concept of slicing of arrays. You can do that. So this is like we'll be talking about slices more clearly. If you want to go through the same array in reverse, you just have to, instead of, so as you said here, this defines the stepping. If you declare -1, this actually goes in reverse. So if you get something like this, it starts with 3 and will go back, and you print this, you'll get something like this. It just goes back and back and back. Okay, so you see, I just have the same array in reverse. Okay, now the next thing is we're going to talk about slices. Okay, so this is something interesting. So you can kind of, so something like this is often also called a slice. It's called a slice of the array. So you've sliced the array, and right now we have shown different ways you can slice the array. And so these are basically, this is what slices are called. And now what we can do is, if you want in Numpy, this is a difference between Numpy and a normal array. So in Numpy, I can define a certain, I can overwrite a certain slice completely. So for example, I have A, if it's a Numpy array, and if I say A 1, 1 colon 3 minus 1, it will change. So everything between 1, so basically items 1 and 2 will get reassigned to -1. But if I try the same thing with a Python array, it's not going to work, it's going to fail. Okay, so we'll see this in demonstration also. So this is one of the positive things for Numpy arrays. Besides being faster, it's more flexible. There are more things you can do with it. So also note that the slices, they're basically just views on the same data buffer. It's not like it doesn't get its own buffer. So it's basically just a view, like a link to the same data buffer. So if you modify that, it's going to modify the original array also. Okay, so for example, so an example of that is, so if I define an array and a slice of it, a comma slice, and if I change the value of the slice, the value is going to also change in the original array. So we're going to see this actually happening. The value over here is given. I think it should be a comma 3. That's all right. And if you really want to make a copy of the data, you need to use the copy method. So this would make a copy of it, and therefore if you make any changes on this, it would not affect A. Okay, so this is one of the differences, something very important when you talk about Numpy arrays. You can also create slices on multi-dimensional arrays. So if you had something like a multi-dimensional array, you can also declare it. So if you want to say access the first row, second column, B1 comma 2, if you ever said B1 and had a colon over here, it basically means in row 1 please access all the columns. Similarly, if you put a colon in the first one and 1 here, it says on the first column all rows. And if you want to, the other method is, if you want to create a extremely funny index, you can also have something like this, where you have so if you want to say access this point to this, you would have the starting row index, ending row index, starting column index, and ending column index. Okay, so starting row index, ending row index, starting column index, ending column index. You can do the same thing. Okay, let us just look at some examples to further make that concept clear with you. Okay, so as you said, Numpy arrays can be accessed as a list. Here I've created A. And if I want to access the first element number 1, it's 5, as I said. If I want to access a slice, so I've created a slice here between 2 and 5. and I get from elements 2 till basically element 4, just before 5, up till 13. A is unchanged. I can declare something like this. So it says go up till element 6 with steps of 2, from starting from 1. So as you said, goes from 5, it will go to 19 and 7. So it's stepped. It started from the from index 1. Please note that in Python, the first item is always a 0. Sorry, the first item is always index 0. So when I write 1, I'm basically looking in some ways at the second item over here. Okay, just clarifying that. Cool. Okay, so A, well, we could even do something like this in principle, and that will not change A at any time, but B would be something different. So if you actually do B over here, as you see, B has got modified, A didn't, so because you've declared it. So if you do something like this, and if you want some modification, please make sure that you're reassigning. There are more examples over here. I've created a larger array, and I can access larger elements. We can again create methods. As I mentioned, if I leave, so this is like a slice going from 5 to 7, and if I don't write the second element here, it basically means go till the end of it. And again, if the first one is missing, it says 3 is the last number. So go start from the start and go till the end of it. Okay, and this basically means everything. Put the whole thing together. Okay, this one says that start from, this is a different slice, a method of accessing the same slice. Please note what the slice is. It is items from 0 to 23. If I do something like this, it says start from the beginning, stop at 10, but do steps of 2. So I started at the beginning, which is 0, did steps of 2, so that's why I have all even numbers stopping before 10. Okay, stopping before the 10th one. And if I want items till 10 from the back side, I just need to put, the step needs to be defined as -1. So if you are a fan of backside, this is the way you can do that. So if we want to work with reversed, you want to work with reversed ones. Second. Okay, so what we'll do now, okay, now let me just finish this section and then we'll take a short break and then we'll come back. Okay. So if I write something like this, what this is starts from 2, takes steps of 2 till the end. This would again start at 2 but take steps of 3, as you can see. So I'm starting at 2 and I'm stepping by 3. So 2 to 5, 8, comma. So 2. This, as I said, again is reversed. If you want to reverse and take steps, you can reverse and take steps. Okay, so what we'll now do is we'll take a short break. We'll take a short break, a couple of minutes, 5 minutes, water, etc. And we will be back immediately. Okay, second is that we will write down here. Okay, guys, I'll be back in a short time. Okay, give me a second. Okay, guys, I'm back. Let's continue where we stopped. Okay, so we were looking at slices. So if we had Numpy array, we had a Numpy array that was declared something like this, and what slices let us do is, it slices, when I did this, it's let me change items from index 1 till index 3, so that's inclusive of 2 to minus 1. And this is something I can't do. This is something I can't do with a normal Numpy Python array. This is something I just can't do. If I try this, it fails. Now, only if I have a Numpy array can I actually handle slices or change a slice or change a part of it. The next, again, we look at more slices. So if I declare a slice, so what we'll now look at is, if I change a slice, how does that affect my normal array? So I've declared an A, I have A is my array, and I've declared a slice which is a part of it from 1 to 5, and as I can see, it's a part of it. If I change the second element of the, if I change the second element, A slice is changed. What happens to A? A is also changed. So that's what happened. So a slice is basically just a view, like a pointer to the original array. So if I make any changes on the slice, the original array also gets changed. So that's something you need to be careful about every time you play with slices. If you really want to make modifications and not change the original array, what you need to do is you need to make a copy of the slice. You need to make a copy, explicit copy, and then work on the copy. If you work on the copy, and so for example, I've changed one of the element on the copy to 800. However, both A and A slice stay unaffected. So it still stays at 8. So if you're playing something, do that. So another example, just to further show you, if I create a copy of this, so I can, here what I've done is I've just essentially I've declared a slice here and a copy of it, but not necessarily first assigning the slice to a to a variable. That also works. Okay, another interesting is I can do, so if I have, this is just another interesting thing, item about this. So if I have y is is a two-dimensional matrix with 2 rows and 2 columns, and x is just a single, is an array with 2 elements, I can do this. And if I do that, what happens, if you look at y, if you can see, it's got changed. So y of 0 got, so I can actually overwrite, as long as the dimensions are are supported. This is something we can do. I can declare x is equal to 0. If I declare y, okay, that does. So if I change x, that doesn't really matter to y because the copy has been made, and then it doesn't really matter. Okay. Okay, I can even do things like this. Okay, next thing is, now we discuss multidimensional arrays. So multidimensional arrays is something which you kind of have to really work with in machine learning, etc. And so it's a multidimensional array with 4 rows and 5 columns. As you can see here, I can access the second. So x comma 1 will give me access to the second row, or to row 2. Sorry, row. So this is 0, this is 1. Same, the concept stays the same. If I want to access a particular element, if I want to access this particular element, it is 1 comma 1. That can be accessed by either 1 comma 1 or 1 and 1 and 2 independent square braces. That also gives us the same thing. Again, over here you can also access things by, you can also access slices. You can define a starting row index, an ending row index, a starting column index, and an ending column index. So here we've got the slice, we've got essentially this slice of this multi-dimensional array, the first common slice. If you wanted to see something else, that's also fine. If I did 2 comma 2 to 4 and I did something like this, as you can see, I've got this slice. So I can access slices of multi-dimensional arrays also in the same method. So you just need to understand slices correctly. If you understand slices correctly, you can use that in any dimensional array of or tensor or an array of any rank. Now this is a 3 comma 3 array, so it's 3 matrices of with 3 rows and 3 columns. And here I have done, as you can see, I have accessed so 0 to 2. So essentially I've accessed you can see it's very interestingly I've accessed 8386. So I've accessed this component. So 1 comma 3 0 comma 2. So I have the first and the first one, sorry, 0th element and this first element, and I have accessed the rows 0 to 2, which you can see. So I've accessed this one, so this row and these 2 rows and columns from this column to this column. So essentially I end up with this point and this point. So this is a very weird little slice I've managed to pick by using this functionality. I've just managed to pick up this component. Well, let me just put it. Yeah, so I've got this section here and this section here. Okay. So you can create really weird ways of accessing multi-dimensional arrays. You can also create interesting slice-like accesses. Here you've done 0, 4, comma 2. So essentially you are starting with 0 and the third element. You'll get it from this element and this element. You would get elements from 0, comma 3. So we've got that. Let me just access that on it. Right, so we've got the entire first item, and then you've got the second part of it, and then in the last component also you got the first 2 rows of it. Interesting ways of accessing it. So you can create extremely interesting ways of accessing multi-dimensional arrays using this. Now another way of accessing this and it lets you access Numpy arrays using Boolean values. Okay, so that we'll look at that. We'll see how to access Numpy arrays using Boolean values. So again, I create an array. This is right now I've created a 12-dimensional array and reshaped it to sizes 3. So essentially I've got 4. I've essentially got 3 rows and 3 rows and 4 columns by using this reshape method. And if I use something like this, give me the rows on, so I can create a NP array that looks like this. An NP array says true, false, true. What that means is that, and if I second, let me run everything here. So rows on, if I define as true, false, true, and if I say apply it on this, what I get is I will get, so note that the first index is true, the second index, so index 0, let me use the correct syntax. So index 0 is true, index 1 is false, index 2 is 3. Index 2 is true. So when I do, what I get is I basically get the zeroth row and the third row, sorry, zeroth row and the second and row, and the third row, or row 2, and row 1 as it falls gets thrown away. This is one way I can access, and please note A stays the same. If I can access it directly also by just saying true, false, true. Alternatively, I can change the index in which I want to access it, and I can say I can set it up this way. If I say true, false, what I get is I get the part from the other side. Okay. So as you see, I get 0, 2, I get 4 and 6 and 8, 10. So this is by accessing it along the columns. So this is where I applied a Boolean choosing or Boolean indexing on the rows. This is Boolean indexing on the columns. Both ways we can do it. Cool. Now let's talk about something else. Very interesting. So again, talking about how linear algebra works, or why Numpy arrays are used. So probably a lot of you would have heard linear algebra forms the basics of machine learning, deep learning, AI, etc. And one of the reasons, so basically you can do a lot of linear algebra functions with NumPy. And you can, one of the things you do is you kind of can represent vectors also using Numpy arrays. So vector, as some of you have learned and still remember, the vector is a quantity defined as with a magnitude and a direction. So vector can be represented as an array of numbers also. That's in one of the easy ways of do. So for example, if you have to show that a rocket is growing up at a slight angle, that it has a vertical speed of 5,000, a slight speed to the east at 10, and a slight speed to the north at 50, the rocket's velocity can be represented this way along the three different axes. That's one of the reasons, and therefore your vector. So this is now becomes and this can be defined as a Numpy array and used in calculations very easily. Now come to into a machine learning problem. So you can do the same thing to define a certain data in machine learning. So, for example, if you have to build a machine learning system to classify videos into three categories, like good videos, it could even be links, it could even be emails. So you want to say it's good, spam, and clickbait. You could essentially do that also by having a Numpy array. Okay. So other ways you can even represent. So this is another way of representing a video information. So for example, if you have this is like a representation of saying that this video has lasts for 10.5 minutes. It had 5.2% viewers, as you can see, 5.2. Give a pointer. So it's got 10.5 minutes. That's 10.5 over here. It's got 5.2% viewers who watched for more than a minute, and it gets 3.2 views per day on average, and it was flagged 7 times as spam. And then you can represent that video in a vector that looks like this, in a Numpy array that looks like this. And this is the reason why Numpy arrays are used so much, because you can even represent complex forms of data using vectors and then use mathematical operations on that to find algorithm and apply algorithms on that for whatever processing you need to do post that. Okay. So yeah, so for example, this is going back to our video classification type. So you could represent say class probabilities of a particular video. So you could say that, so after you run it through a machine learning algorithm, you would get something like this. You would get that, hey, this video is probably 80% I think it's a spam, 18% I think it's a clickbait, and just 2% I think it's good. Okay, so this is what this is a very commonly used methodology. This is a classification. So if you're working with machine learning classification, you would typically have to classify an object into multiple types. Either, so for example, you've used a V concept, you've used an example of a video. It could be spam, clickbait, or good, and they each have probabilities which equal to equal. The sum of the probabilities will come to 1, and you would represent it this way. Okay. So Python, as you mentioned, can be just a regular list of numbers. Machine learning uses lots of scientific computation, and therefore it's used to use Numpy arrays, which provides a lot of. So the functions that Numpy provides is much faster than those of Python. Okay, that's, and now we'll have an example to show that. So essentially, Numpy functions, or what we've called here vectorized functions, are much more efficient than writing the same thing in Python. Okay, now what we'll do is we will implement matrix multiplication in two methods. One is by the normal matrix multiplication, and the second type is by using an inbuilt operator from Numpy. So we'll call that multiply vector, and here we will implement a normal loop based matrix multiplication. Okay, and we will see what it looks like, and we will operate it on two matrices of size 100 by 100, and we will check how much time it takes. Okay, so as I mentioned, we are going to do matrix multiplication. So this is a normal matrix this is matrix multiplication normal code, where we are basically multiplying the rows I comma j. It's essentially the transpose and multiplied by each of it. I'm not going to go through into the code, but that's what this is. And the Numpy implementation is very simple. We have an at operator which gives us a matrix multiplication, and we just do return A at B. Now what I'm going to do is I'm going to run both of them on 200 by 100 matrices, and we'll compile the time. So there's a very function called time it that lets us compile the time. This is taken 5.38 milliseconds. This is taken 38 microseconds. So this is a lot faster, as you can see. So that's why it's usually recommended that you continue using the vector method over other methods. Okay, these are some more examples of reshaping, etc., which you won't do. Now we'll talk about some basic operations with Numpy arrays. So what kind of what can you do with Numpy arrays? So you can do addition. As simple, I've defined two arrays. So as long as the two arrays are of the same size, I can add them. I can add them easily. There are other methods also I can do. I can add them. Now if this A is an array and B is just a value of say 4, or sorry, again an array. I can add both of these. Okay, and it's the same. So this same addition is like, I can write in a for loop and also do it, but I don't need to do it. It's easier to do it with Numpy. It'll give me the same results, as you can see. Please note if the shapes don't match. So if I do, this is rank 2 and this is rank 4. This is a 4 this array has 4 elements. This array has 2 elements, and if I try to add it, it will fail. So while adding, I have to make sure that the dimensionalities kind of have to match. We can do subtraction also, not a problem. So multiplication, Numpy supports both element-wise multiplication. Let me just tell you what element-wise multiplication is. So if I have two elements A and B, sorry, two matrices A and B over here, and element-wise multiplication, which is dominated by A asterisk B, is effectively multiplying each corresponding items together. So 1 will get multiplied by 2, this will get multiplied by 0, this will get multiplied by 3 over here, year 1 will get multiplied by 4 as we have represented. And here we have shown again both methods. So this is element wise multiplication. This is not, please note, this is not matrix multiplication. This is element wise multiplication, where we just multiply the corresponding elements of the matrix with each other, the corresponding ones. Matrix multiplication is represented by np dot, by using the function np dot. So if we did np dot a comma b, and I printed it, and this is as if this is the normal matrix multiplication which you have probably seen, and we have implemented matrix multiplication over here to show you that it's the same here. Okay, so you can, these are the various items you can do. You can do division, no problems. So again, both the elements are the same size, you can divide it. Here again, I'm going to divide a by b by concept of integer division. So by integer division, I'm essentially getting only the divisor. So basically, here it was a proper division, here it is the integer division. As you can see, I've got the integer values. The cross, two crosses is integer division in Python, and I can just do it with two arrays and I can get element wise integer division. I also can do modulus or remainder. Okay, so this is modulus or remainder. This essentially gives us the remainder of an element wise division. So I've taken element here and we've divided. So basically, please note b is values from 1 to 4, and I've divided each one of them. And if I have a remainder, so for the first, if I divide 20 by 1, I don't have a remainder. If I divide 30 by 2, I don't have a remainder. If I divide 40 by 3, I have a remainder of 1. And if I divide 50 by 4, I have a remainder of 2. That is what this is showing. So this is modulus or remainder operation. So these are basic operations, and you can build anything on top of it. Similarly, you can also do an exponent of two matrices, of two arrays with each other. So I have A and B again of the same ones, so I can get very simple element wise exponentials. So here I have raised 20 by 1, 30 by 2, 40 by 3 and 50 by 4, and I have got values over here. Another way of doing the same thing is by just using np.power a comma b, and I would get exactly the same result. So there are two ways in which I can do power, by just doing a 2 stars or using np.power. Okay. Let me just summarize that again. So we use, as we specified, we did addition, we can do subtraction, and element wise we can do element wise product, as we've seen. We can do matrix products, element wise production. We can do division, we can do integer division, which just gives us the divisor inside, or we can do the modulus or remainder operator, which just returns us the remainder from a element wise division. We looked at exponents. And then we're going to also look at what's called conditional operators. Okay, so if I can even do conditional operators. So I can just check, say that, hey, if I have an array of this and I want to compare that with another array. So element wise comparison. So for example, I have another array which 15, 16, 35 and 36, and the comparison I want to have is less than, and I can just say m is less than this, and the result would give me the result of the comparison. So it essentially says, okay, it compares 2 and 20 and 15, so that is 20 is greater than 15, so that result is false. Minus 5 and 16, minus 5 is smaller, so that is true. 30 and 35, 30 is smaller, so that is also true. 40 and 36, that is not true, so I have false. Or so other examples, I can use 25 over here and doesn't matter. Now, if I use, what I can also do is that if I do this comparison, m is less than 25, and I just want to find the items that's less than m is where the values, individual values are less than 25, I can just use this also. Okay. For example, I take m and I said in m, give me the values less than 25, I would get something like this. Okay. So we will see that before we go to broadcasting. So this was the we did. We had m defined as 20, minus 5, 30, and 40, and we had m less than. This is the other array which I want to compare it against, and I can get the result of the comparison directly. And if I want, I can also get, say, find the items which is less than 25 by using an operator like this. So where m, and I say inside that, I say give me the values less than 25, I can get that. Okay. Now let's look at an interesting concept called broadcasting in Numpy arrays. So broadcasting in Numpy arrays is, so what is broadcasting? So we've seen element wise addition. So where if two arrays have identical we have the identical the ranks are the same, the shapes are the same, it's very easy to do it. Now what happens is and we've seen that the shapes are very different, it fails. But what happens, but if there's some sort of compatibility to the shapes, that can do actually. So if you have something like this, what happens? Well, in general, so Numpy expects the same shape, but if it's not true, it applies what's called the broadcasting rules. Now there are two types of broadcasting to remember. Okay, there is a request from somebody for the presentation of the notebook. So if you have registered for this for this webinar, you will get an email with the presentation and the notebook, so which you can, and the video, which you can view at your own leisure. Okay. As I mentioned, there are two rules of production. So if I do something like this, so the shape is looks like this, and there's just here the shape is 1 comma 1 comma 2, here the shape is 5, it's like it's a single scalar that's getting added. What happens is that this number gets added to all of it together. Okay, so what essentially happens then, one will get prepended to the smaller ranking until the rankings match. So it will just, you just add it everywhere effectively. Okay, as you see, 1 comma 3 gets added everywhere. So 1 comma 3, 5 got added to 1 and 5 got added to 3. That's effectively what happens. The same thing just keeps, effectively you can say this became this effectively became another 5 comma 5 with the same rank, and it got added effectively. That's what seems to have happened. And that's the first rule of broadcasting. Okay, and we can do that. So this is the second rule, which says that, hey, if you have something like this and you have something like this, the whole thing gets added to each other. Similarly, if you have np.1s, so you have some, if you have a n-dimensional array of say 3 comma 3 and something that's just a rank 3 over here, this will get added, this will get extended say 3 times and will get added to this. Okay. Similarly, if you've got something like this and this will get added 3 times, this will get pulled 3 times, and it will create it. So these are concepts called broadcasting, which helps you to which is quite powerful at times and makes it very easy to do. The second rule of broadcasting is that on adding, let's just look at that. We'll just look at it. That was called the second rule of broadcasting. So let's look at some hands-ons. We're coming towards the end of it. Let's look at some broadcasting rules. So I have defined a value, an array H that looks like this, B looks like this. I can say H, I can just add it here. So again, please look, the ranks are different, but it will add it. Okay. And similarly, I can also add B to H. So in spite of the fact that the shapes are quite kind of different, but I can kind of match it together. Now let's look at another value where it fails, where I've defined K. I've defined values between from 1 to 6, and I've redefined the shape of 2 comma 3. That's basically a matrix with 2 rows and 3 columns. And if I want to then add something like this, which is an array with 3 rows, 3 elements, that kind of works. And effectively what it's done, it's essentially added this 2 times to each of those rows. That's what's happened effectively. But if I try something, give it a weird shape like just with just 2 elements, that won't work. Okay, so if I can kind of do but if I, okay, so note that the shapes have to be kind of compatible. You can say in some ways it has to be a divisor of it, or has to be like I should be able to add multiple instances of it to manage the shape of the bigger one, if that's possible. So I've got 2 matrices each, and if I can match, if the smaller one's shape can be matched to the shape of the bigger one by just adding multiple instances of the smaller array, then it's compatible. That's what we had seen before. So for example, I have K, and if I just want to add a scalar called 5, that also works pretty fine. That's also neat. Okay, so this is kind of a nice representation of that. So here I have different types of supposedly different arrays, but you can see if I have something like I have a 3 element array, and here I have just 1 element, but I can effectively say that I can have it 3 times and make it compatible to the larger one. Similarly, I might have a 2-dimensional array here and a single dimensional array here, but I can multiply that, I can add that several times and get the same value. And even this is possible, or even this is possible. We can even do this. So because this can be multiplied 3 times, this can be put 3 times and built into a shape that's compatible. So the reads of broadcasting. Okay, the next things we'll be looking at is we'll be looking at some statistical functionalities which are available in Numpy. So as I said, Numpy is good for matrix for manipulations, and so it's got a lot of statistical and arithmetic operations which you can use to do something very easily. What we'll do is we'll just directly do a demo of this. So so we can do means. So I can define an array, I can define a mean of it. So similar to mean, there are other methods which are also available. I can get min, I can get max. We can get sum, which is basically sum of all the elements in the array. I can get a product, which is basically the products of the elements in the ND array. I can get a standard deviation of the elements in the array, and I can get the variance. These are all very popular methods in statistics. All of them are available directly for us. Okay, and so we will do that and just show you how that works. It's very easy. They just access by something like a.min, a.max, a.sum, a.prod, a.std, and a.var will give you the same thing. Okay, let us look at that. Right, so here I've defined A as an NP array. It's again a two-dimensional array, essentially 2, 3. and I can say give me a dot mean, and this would give you the mean, the average of all the elements in this of this matrix. And p dot product would give you the product of it. Well, this is demonstration. The product is, you can just multiply all of it and you will get this. Similarly, you can get this is actually the derivation of the standard deviation and variance, and this actually shows that the standard deviation, the standard deviation and the variance calculated by numpy and calculated with the standard formulae will come out identical. And well, that's just proof, but if you really want to use them, you can. So this is a nice little function where we showed all of it together. So I have a dot in, a dot max, a dot sum. So these are different functions I've put in a for loop, and I'm going to execute each of these functions on a, and I did that. And so as you can see, I'll just look at a once more. Okay, so you just can get that. Cool. Okay, now there's something very interesting here when you talk about n-dimensional arrays, which we had mentioned before that when we're working with n-dimensional array, each dimension is called an axis. Okay, each dimension is called an axis. Now let's look at, so I'm going to define, C, and so this is what I've defined. So C is basically, first what I did, I told it to make an array that goes from 0 to 23, so to a 24 range array, and I told it to shape into 2, 3, 4. So it made it into two arrays, each and each matrix has 3 rows and 4 columns, as you can see here. So I have got, please note, I've got 3 dimensions, or that's called 3 axes. Okay, I can got 3 dimensions, but instead I got 3 axes. And I can say c dot sum when axis is equal to 0. If I do this, what's it's effectively done is it's effectively looked at the first dimension, that's this dimension, that's, you can see this, the first dimension, that's 2, that's what I'm accessing here. So it's basically what it did, it's basically added both these matrices with each other, essentially looked at this matrix as a difference matrix and this as a matrix, and gave me a return, an array that's 3, 4, which is basically just an addition of these two matrices. And if you look at it, you can see it. So 0, 0 and 12 has been added. We got 12 here. 4 has been added with 16. I got a 20 here. 8 has been added to 20, and I got a 28 here. Similarly, if you look at each of these values over here, it's the sum of the corresponding values in these two matrices. Okay, so this is the same. So effectively, I have done is I have flattened out this axis out. Okay, I've flattened the first axis. So first axis is equal to 0, and we can do that. Similarly, I can say that, hey, sum it across the, yeah, this is the row. So this will give me the row sum. So if I say sum axis equal to 1, so first row, you can say, was the first index was the number of the matrices. The second row, the axis equal to 1, is basically the row. So what I've done right now, I've basically summed the row sum of each matrix. Okay, so what I'm doing is I'm summing across the rows. So I'm summing over here this and this comma this here and this here. This is what I've got here. As you can see, I've summed this row into this. Oh no, sorry, I did that here. And what I've done is I have summed the rows. Yes, so what I've done is I have 12 is, yeah, 0, 4, 8, 12. And then I summed all the rows in this matrix. So 0, 4, and 8 I've summed. I've got 12 here, 12, 16, 20 I've summed. I've got 48 here. 1, 5, 9 I summed. I got, so 1 plus 5 plus 9, that's 15, which is over here. 13, 17, 21 I summed, that's 51, that is over here. So you can see here the summing is happening across the rows, because that's what I've said, that's a row sum. And similarly, if I put it across axis is equal to 2, what I get is a column sum. So here I've summed it across the columns. Okay, and I have the same thing, I have summed across columns now. And I can see 0, 1, 2, 3. That gives me 6. Okay, 4, 5, 6, and that gave me 6. 4, 5, 6, and 7, that will give me 22 over here. 8, 9, 10, and 11 will give me 8 plus 9 is 17. 17 plus 28, 10 is 28, is 28. 28 plus, 17. 17 plus 10 is 27. 27 plus 11 is 20. This is 38, which I get here. So this is the sum across the columns. So I have ways of summing the same n-dimensional array across multiple dimensions by using Numpy functionality, by using the axis, the variable called axis. Okay. Next we look at, so Numpy also gives us very easy methods of doing transposes of matrices. So for example, I have an array here. So let me just first print A, and I can print A. The A transpose is just available as A dot T. So you can see I get the transpose of this matrix. Okay, so this is A, and A dot T gives me the transpose of this matrix. So that's an easy way of doing this. A dot sum axis is equal to 0, and then yeah, I can do the same thing. I can sum across axis is equal to 0, which will give me the axis across the rows, the sum across rows, and if I do axis is equal to 1, I get the sum across columns. Okay, now to finish with, so we are at the end of our lecture. So to finish it, what we'll do is we'll show how with NumPy you can easily solve even linear simultaneous equations very easily. So for example, if you have an equation to solve which is say 2x plus 6y is equal to 6 and 5x plus 3y is minus 9. So NumPy gives us access to something called line alg. This is a linear algorithm. Essentially it gives you it just helps you solve linear simultaneous equations, and it needs two inputs, obviously, as you can understand. So it needs these coefficients and it needs the outputs. Okay, so you just specify the coefficients in as a matrix. So this is like those we used to use matrices in school to solve simultaneous equations. Very similarly, you specify a matrix. So 2, 6, as you can see, I have 2x plus y, 2x plus 6y. So 2 and 6 come here. 5 and 3 come in my second row. 6 and minus 9 go in something I've called depth vars in my second, or the dependent variables, or you would say the outputs. You could specify that, and I just need to send them into to line alg. So I can say is line alg dot solve coefficient and depth vars. If I run that, I have a solution. I have minus 3 and 2. And if you want to check that, we can just do coefficients or dot. Like this is a dot product, essentially executes this 2x plus 6y and 5x plus 3y. And so what I've done is I have I have sent the solution to the coefficients, multiplied it, and see if I get the answer. And you can see the answer is 6 and minus 9, as is over here. So here with Numpy, you can see I can easily solve multiple linear equations in a jiffy without any problems. Okay. So this kind of completes our presentation or an introduction to Numpy. For people who are just looking at it for the first time, it does look like a lot. So that's why we are presenting the video, and the notebook that is being presented today will be sent to all of you along with the PowerPoint presentation that was shown over here. So you can take a look at it and try it at your own pace and get used to it. Okay? So to do that, all you need to do is you need to please fill in the PowerPoint presentation. Please fill in the Excel sheet which we have shared with you, and we will give you access to. We will share the access to this notebook. That would be it, folks. So I hope you've learned something useful today. You could take and if in case you want to take a or continue or pursue a career in Python and machine learning, you would have to get more comfortable with NumPy and with Pandas eventually. If you want to get more comfortable with if machine learning is what you want to do, I'll just take you to the slide which I showed before. So today what we did was NumPy. This what we do is NumPy. The other libraries are interesting are Pandas, Matplotlib. You use Scikit-Learn if you want to do more machine learning, and then if you're getting into TensorFlow, if you want to do TensorFlow, if you want to do deep learning, what's called normal AI, etc., you would have to use TensorFlow. But the base of it, it's all NumPy. So you need to really get comfortable with NumPy because all of these effectively use NumPy, and they will use a lot of the functions and methods which you've seen today all the time. The reshaping, etc., is all used a lot. Reshaping the slice operations, broadcasting. All these operations are used a lot in more advanced algorithms like Scikit, in more advanced libraries as Scikit-Learn and TensorFlow. Okay. Okay, folks. Thanks for your time. And in case you're interested in some courses, please take a look at our portfolio. We'd be happy to help. In case you have other questions, you can shoot it to our to reach us at CloudxLab.com. And at the end of it, in case you have any questions, I'll just go to the last slide. So in case you have more questions, if you can either send us an email to reach us at CloudxLab.com. If you want to discuss topics which we have seen today, you can discuss that on Discuss forum at https://discuss.cloudxlab.com. And we'd be more happy to help. In case you want to get in touch with me, my LinkedIn link is in this PowerPoint presentation. You can just click there and stay in touch. Okay.
The executive PG certificate, and that's the reason why IIT came up with this, and we joined hands with that. And so we basically, the way we design the course is that the course should have the perfect combination of theoretical as well as practical, and that's done by bringing the professors from IIT as well as bringing the industry experts. So we have a person from NASA, a senior engineer from Google, my co-founder, who has a great experience in engineering and data engineering, DevOps, and machine learning. Then we have Praveen from semiconductor industry. He is an expert in the computer vision, and myself, I am passionate about this field. So the industry and academia, we combine together to produce one of the best courses on the planet. And this is essentially one of the deepest range of courses or the PG certificate that you will get ever. I mean, this is equivalent to your master's, where you don't have to leave your current job in order to do the master's. All you have to do is spend at least 1 hour every day on working on the exercise, learning with the content, and getting ready for the weekend session with the professor. So the executive course, we basically learn, so there are 3 variants of the same course. One is the data science, other is AI, and third one is MLOps. Okay, so the course on data science covers basically the course on data science covers everything except for the deep neural networks and the operation part. The course on the AI covers everything and covers everything till the deep neural network. And course on MLOps covers how do you understanding of the machine learning, along with how do you productionize the machine learning models. Okay, so this is the table that shows you what is there everywhere. So a quick way to look at it is that the foundations is in all, machine learning is in all, deep learning foundations is in all the 3 PG certificate course, and the DevOps foundations is common to all, right? Now, the advanced deep learning is only in the AI course. This is AI course, this one, okay, the AI course, and the advanced DevOps ideas are only in the MLOps and so on. So the entire, like the whole structure is going to be similar in all the 3 courses, except for the specializations. Okay, so the MLOps one specializes in the DevOps. The machine learning course, the AI course is going to be the deep learning course is going to specialize in the advanced deep learning techniques, while the data science course is going to specialize in the data engineering on a large scale. So this is holistic. This is basically including the distributed computing, the data processing on small data, big data, and so on. Okay, there are only few seats left, and you have to hurry up in order to apply. There's no application fees. You can apply. The process of application is that you have to finish an online test. Then there is going to be the review of your application, and then there's going to be an interview, interview one of the teammates. And after that, after these 3 steps are done, only once you qualify for the course, you will get the offer letter. Okay, so even though this is like fairly restricted entry in the course, there has been a tremendous demand of this particular course, the PG certificate course, and the seats are filling extremely fast. Okay, so so you can take a look at this comparison chart on the website as well in your own free time. So this is that's all about it. So I want to take up your questions now. All right. A question from Vicky is that, can you repeat in which program computer vision is covered? Computer vision is covered in the PG certificate with AI or deep learning. All right. Okay. With respect to the course fees, you can see on the screen, and And the good part is that we have monthly EMI that solves a lot of issues with respect to money. We have kept our own EMI model rather than tying up with the bank or somebody else. So this reduces your overhead of the interest rate. Okay. Thank you so much. I had a wonderful set of questions, and I wish all of you the best. If you have any questions, do come over to our discussion forum, do drop us an email, and let us know if you have any questions. I really enjoyed your set of questions, and I look forward to see you in my class. And this is essentially IIT Roorkee's program, and they are owning it, but I'll be basically supporting the entire course personally. All right. Thank you so much. I had a wonderful discussion today. I hope this was useful to you in understanding AI, machine learning, data engineering, DevOps, and the general terms that are being used over there. All right. Have a good day. Bye-bye.